All right, graphing linear inequalities. So we don't really solve linear inequalities in this class. We try to limit the amount of algebra that we do. So there's only one thing about solving algebra of these that we'll talk about in here that can be kind of tricky. But an inequality is like less than, greater than, less than or equal to, or greater than or equal to. And we're going to focus more on the graphing of them. So this one right here, you have a point. So this is just like we do where the x is 3 and the y is -2. And we're going to plug it in and see if it works. The thing that's different about this, we put a 3 in for our x and a -2 in for our y, is it doesn't have to equal 5. If we plug in any point and we get a number greater than 5, then we're good. So this is minus a negative, so this is 6 plus 2 is 5, which is 8 is greater than 5. Sorry, I hesitate because I feel like I put 7 last class, but it was 8 a.m. So that is true. So that point is a solution to these. So what we'll see when we graph these is the solutions to a line is a line. The solution to an inequality is actually an entire area. The next one, again, same idea here. We're just plugging in a -1 for x and a 4 for y. So when I plug a -1 in for x, I get, and a 4 for y, -1 plus 12. We're seeing, is this less than or equal to 10? This, I end up getting 11. 11 is not less than or equal to 10, so this one is not true. So you are just plugging these in and then comparing the symbol at the end to see if it is less than or greater than or less than or equal to or greater than or equal to whatever they show you there. All right, so on to graphing these. There are 2 extra steps that we have to do graphing these, but the main steps are exactly the same as if it's equal. So like this one, when you see x is a number, when you say x equals any number, you automatically are thinking that it is a vertical line, okay? That it is a vertical line. So if you forget, you just go to x equals -3, and you think if I draw it this way, it doesn't make a whole lot of sense, so I'm going to draw it this way. Now, before I draw the line, the 2 differences when you're doing inequalities. The line is our answers, like our answers at work. So if it is less than or greater than, you actually do what they call a dashed or dotted line to signify that it can't equal that. If it's less than, that means it can't equal that. If it's less than or equal to, you do a solid line. So this one is x is greater than or equal to -3. So we do a solid line here because it can equal that point. It can equal the stuff on the line. And then the second thing you do is you're going to shade. I said your answer is an area. So this is any point that's greater than or equal to -3 is going to be my answer. So greater than, the x's get bigger as they go to the right. So I'm going to shade on the right-hand side here. On Alex, there is a paint bucket that you'll just drop on that side. But you always have to shade on this to signify, because any point that's greater than, where x is greater than or equal to -3, is going to work for this. On the next one, it is y is less than 4. So again, when y equals a number, it is a horizontal line. And remember, like I just said, if you get stuck, go to y equals 4. And it doesn't really make sense to do it this way, so it is going to be this way. This one's just y is less than 4, though. So this one is going to be a dashed line. I'm going to go back up here and write solid just because I forgot. Sorry. This is going to be a dashed line. So because it is just less than. That signifies that we cannot use 4, because y cannot be 4 because it has to be less than 4. And then here when we shade this, it's less than 4, so I'm going to shade below 4 because we want when y is lower than 4. But that dashed line is important because it does signify that you cannot equal that line. Like you cannot have a point on that line. We can have any point below that line, that's fine. On Alex, there's just a button where you can alternate it between the solid and the dashed. So it should be easy to change those. All right, getting into like y equals mx plus b. Again, you're going to do this just like a normal like y equals mx plus b. You just got to do the dashed or solid and then shade, okay? So on this one, we are going to go, I'm writing y equals mx plus b underneath since this is our first one. So my m is the number in front of x, so that's 2 or 2 over 1. So I go up 2 to the right 1. And my y-intercept is -1. Remember, that is my starting point. So when I graph this, I start at -1. I go up 2 to the right 1. And before I draw the line, go back and look. Okay, this is y is greater than, so this is going to be a dashed or dotted line because it's not equal to. All right. When we go to shade this, when you have it in y equals mx plus b, like when it's in this form right here, you can actually just do, if it's greater than, you shade above. If it's less than, you do below. But like above is going to be over here. But sometimes it's hard to see because it's like diagonal, whether it's above or below. So what the recommendation is on this is, if you have trouble seeing that, is to plug in a point that's not on the line. So like the point that I'm always going to try to use is 0, 0. I can use that almost like 95% of the time. So you plug a point that's not on the line. And when I plug that into this, when I plug that into the original one, I plug a 0 in for the x, a 0 in for the y, I get 0 is greater than -1. And that is true, right? So since that is true, the rule is we are going to shade towards the point. Okay? Shade towards the point that you pick. So that means since 0, 0 worked on this side, since 0, 0 worked on that side, that means every point over here will work. So we are going to shade on that side. So you plug in a point, and if it's true, you shade towards that point, and if it's false, you're going to shade away from that point, okay? Because every point on this side will work, and every point on this side will not work. Every point on this side that I plug in will give me a number greater than the right side. Every point that I plug in here will give me a false thing. We'll see that in a second. All right, so do another one of those. I get y is less than or equal to -1/2 x plus 3. So as soon as I see the less than or equal to, I can, go ahead and write solid somewhere so that I know that it's going to be a solid line. My y-intercept, my slope is the number in front of x, -1/2. So that is down 1 to the right 2. My y-intercept is my 3, so I'm going to start at 3. So I start at 3, I go down 1 to the right 2. We said it was a solid line. So I have my line right here. So this is y is less than or equal to -1/2 x plus 3. It's less than or equal to, so I should shade below. And again, if you see that, that's fine. It's going to be right, and it's going to work if it's in y equals mx plus b. But let's plug in a point to be safe. So let's plug in 0, 0. 0 is less than or equal to -1/2 times 0 plus 3. That 0 is less than or equal to 3. That's true again, right? 0 is less than or equal to 3. So I shade towards 0, 0. So again, shaded just like it's y equals mx plus b, but you have to dash or solid and shade in one side or the other. All right, so what happens if it's not y equals mx plus b? The easiest way to always do these is to go ahead and turn it into y equals mx plus b. So I am going to do some algebra here to get y by itself. So I get subtract 3x from both sides. 2y is greater than or equal to -3x plus 6. You do this just like it's an equal sign. Divide both sides by 2. So y is greater than or equal to negative 3 halves x. 6 divided by 2 is 3. Make sure you divide everything on the right side by 2. So negative 3 divided by 2 and 6 divided by 2. My slope is negative 3 halves, which is what? Negative. So it's down 3 to the right 2. And my y-intercept is 3. 1, 2, 3. All right, it is greater than or equal to, so it is a solid line. My y-intercept is 3. My slope is down 3 to the right 2. We said it's solid. So now, again, plug in a point that's not on the line. So if we plug in 0, 0, I always like to plug it into the original when it's in this form because I just feel like it's easier to work. You could plug it into this one or this one. I don't want to deal with the fraction, so I just plug it into the top one because that all becomes 0. So 0 is greater than or equal to 6. Oh, that's false, right? 0 is not greater than or equal to 6. So first false one. So here we shade away from the point. Okay, so we're going to shade this side. And again, if you are really good at seeing these, some people can see it, some people can't. This is greater than or equal to, so that means I shade above. Do not look back at this one. Look at the y equals mx plus b. Greater than or equal to means I shade above the line. That will work if you can see that. But you can always plug in a point to be safe. So we plugged in 0, 0. And since it's not true, we shade away from it. All right, so algebra-wise on these, you do everything the same. I want to hide that right there for a sec, see if you remember. Go back up, sorry, yeah. So solving these for y equals mx plus b, you do algebra just the same to get y by itself. There is one catch to these. Here I subtract 4x. Does anybody remember the one catch? I get negative 4x plus 20. When do you flip the sign? Yes, if you ever divide by a negative, you have to flip the sign. Okay, so I wrote that down here. I was trying to hide it from you. This is just a rule that with inequalities, the way they work, to make them hold true all the time. If you ever divide by a negative, so here we have to divide by negative 5. We divide by negative 5, so I'm going to flip the sign. Negative 4 divided by negative 5 would be 4/5. 20 divided by negative 5 would be negative 4. Anytime you divide by a negative, you have to flip the sign, okay? We are only, for algebra purposes, we are only like trying to make it into y equals mx plus b. So anytime you have a negative next to your y is when you're going to flip the sign. So if you ever divide by a negative, you flip the sign. Here my slope is 4/5, so that's up 4 to the right 5. And my y-intercept is negative 4. So 1, 2, 3, 4. 1, 2, 3, 4, 5. So I'm going to start at my y-intercept, which is negative 4. I go up 4 to the right 5. Oh, it is dashed, isn't it? Because it's just less than, or I guess it's greater than when we flip the sign. So it is a dashed line. So again, if you're just looking at it, you're doing greater than, so we should probably shade above here. But let's check it with the 0, 0 point. I'm going to plug it in to the original because that's just easier to work with. 0 is less than 20, so we do shade. But you can still find like the x-intercept and the y-intercept on these. Remember, you find the x-intercept by making y be 0, find the y-intercept by making x be 0, and solve them that way. Like it's still, you still can do it. I just always like to put these in y equals mx plus b because I feel like it's easier to work with. All right. So we did systems of equations last week. So So now we're going to do systems of inequalities. With system of equations, we could graph them by hand, which was kind of hard to see where the intersection was. Remember, our answer was the intersection of the point. But we did by graphing in the two algebra ways, substitution and elimination. With graphing inequalities, the only thing you can really do is graph them, because we are actually going to look at the intersections of the shading to figure out our answer here. I don't know if I'll show you that on this. Yeah, I'll show you that on this first one. That's fine. All right, so the first thing, I'm going to graph my red line. My slope is 1 over 1, so that would be up 1 to the right 1. And my y-intercept is -2. So I start at -2. Up 1 to the right 1. All right, so my red line, I start at -2, up 1 to the right 1. It is a dashed line, right? Because it is just greater than. When we go to shade, I'm going to go ahead and just pick a point. Whoops, sorry. So when I pick a point, 0 is greater than 0, -2, 0 greater than -2, 0 is greater than -2. Okay, well, since y'all are, if you have different colors, you can do this for one of them, but I'll show you the way to do this without being a big mess. I got different colors, so it doesn't look as bad. I'm shading towards the point, okay? So for right now, if you don't want to make a big mess on your paper, just put a little arrow, like to signify that you are shading that way, so that you can come back and look at it in a second. I'm going to go ahead and shade all of it just so I can show you like the visual representation of what we're doing here. So I'm shading towards the point. My colors stand out a little bit more, but all right. Y is the next line, the blue line. Y is less than or equal to 3. Remember, that is a horizontal line. Okay. So I start at 3. It is going to be solid because it's less than or equal to. Since it is less than or equal to, I'm looking at numbers below that line, right? So again, if you want to just put a little arrow to shade that you're shading that way, you'll see what I'm going to do in just a second. So I'm shading below the line would be right here. Okay. So my answer is the intersection of the shading. My answer is the intersection of the shading. So my answer on this one is actually right here. Actually, let's do this. Let's see if I can make it real. My answer is only this area right here. And this is why I say, just if you have pencil or whatever, if you're doing it on paper, and this is the way I'll do it from now on because that looks really confusing, is just make a little mark, okay? You're going to make a little mark and say, okay, I'm shading above this line, I'm shading below this line, so the only answer could be this area right here. And you'll see that on the next one. But I just wanted to show you visually what you're doing here. When we did system of equations, it was the intersection of the line. It's just that one point was the answer. Here it's an intersection of the area that's shaded, so you got a bunch of different answers in that green area right there. All right. This one, my red line is x is greater than or equal to 0. So it's going to be solid, and it's going to be a vertical line. Well, greater than or equal to 0 is actually just the y-axis, like I'm drawing a line right here. This is something that happens a lot in real life, and we're going to talk about the real life stuff on Thursday. But if I'm doing some kind of profit margin and have this product, how many ever products I create or manufacture is always going to be greater than or equal to 0, right? I can't have a negative amount of products. So we'll talk more about this on Thursday, but this is the idea here. Like, you see this a lot, this greater than or equal to 0, because I'm always dealing with a positive number. So I'm always dealing with a positive number. That means it's going to be to the right. So this is what I'm talking about. Just make a little arrow there to the right. Don't draw the whole, shade the whole thing, because that gets confusing. So, but now I remember that I'm going to do that to the right. On my blue one, my slope is -1 over 1, so it's negative. So I go down 1 to the right 1. And my y-intercept is 4. So I'm going to start at 4, and then I'm going to go down 1 to the right 1. This is a dashed line, right? Because it is just less than. That wasn't very pretty. So I do less than or equal to, or I'm sorry, less than, I'm doing dashed. Less than means I probably should shade below it, but let's check it algebraically. So let's plug in a 0, 0. 0 is less than negative 0 plus 4. Is 0 less than 4? Yes. Okay, so I'm shading towards that point. So now with my little arrows, I need to be to the right of the red line and below the blue line. So my answer is going to be this area right here. To be to the right of the red line and below the blue line. All right, so same idea on this. Yeah, we are on the next one. We are doing the same thing. You're graphing two inequalities on the same picture. Just go a little bit harder problems here to look at them, but it is still the same idea. All right, so my red one here, I do want to put it in y equals mx plus b first. So I'm going to subtract 2x from both sides, so I get y is greater than or equal to negative 2x plus 4. My slope is negative 2 over 1, so that would be down 2 to the right 1. My y-intercept is 4. So I can start at 1, 2, 3, 4, and then go down 2 to the right 1. Start at 4, down 2 to the right 1. It is greater than or equal to, so it is going to be a solid line. And then I got to figure out my shading. So let's plug in 0, 0. You can plug in any point that's not on the line. I'm going to plug it again. I like to plug it into the top one there. So 2 times 0 plus 0. Oops. That's greater 0. Greater than or equal to 4. 0 is greater than or equal to 4. No. So that means I shade away from this. So again, I have to do another problem or another line. So I'm just going to put a little arrow. I got a shade above that or to the right of that red line. My blue line, to get it in y equals mx plus b, I'm going to subtract x. So I have negative x minus 6. And then I need to divide by negative 3. When you divide by a negative, you flip the sign. And divide everything by negative 3. So negative 1 divided by negative 3 would be 1/3. Negative 6 divided by negative 3 would be positive 2. So my slope is 1/3. That would be up 1 to the right 3. And my y-intercept is 2. So my blue line, I start at 2 and I go down 1 to the right 3. Oh, it's up 1 to the right 3, isn't it? Sorry. Up 1 to the right 3. And it is going to be a dashed line because it is just greater than. It is greater than, so I'm guessing I'm going to shade above that line, but let's go ahead and check it. When I plug in 0, 0, I get zeros less than -6. That is not true. So I do shade away from 0, 0. So on this one, I kind of need to be to the right of the red line and above the blue line. So that would be this area right here, right? All right, let's do, I'm going to skip that one. I can come back and do it if we need to, or on Thursday. Let's do one more. So what we're leading to, we didn't do this with equations, but what if we have 3 lines on one of these? This is very common to do, where they have 3, because maybe you have I did a business thing earlier, so like a product where you're manufacturing and then supply and demand where it meets it. We'll go into a lot more of those details on Thursday with the real life scenarios here. But let's graph these. All right, so the blue line right here, y is greater than or equal to x. My slope is the number in front of x, which is 1. So that's positive 1, so up 1 to the right 1. And my y-intercept is 0. So I start at 0. And I go up 1 to the right 1, and this is a solid line. Now, I've said this a bunch, but when we go to shade, we want a number that is not on the line. So I cannot use 0, 0 on this one because it goes through 0, 0. So I'm just going to use this point right here. Let's use 1, 0. It's always nice to have zeros in there. So my 0 is y, my x is 1. Is 0 greater than or equal to 1? No. So that means I'm going to shade away from that point. So I shade this way. I know my purple line's down there, but let's go to my red line next. My red line, my slope is -1, so it is going to be down 1 to the right 1, and our y-intercept is 5. So I start at 5 and I go down 1 to the right 1. This is less than or equal to, so I am going to do a solid line. And now I got to figure out my shading, right? So I could plug in 0, 0 to this one, but since I've already labeled this one like 1, 0, I'm going to just use 1, 0 again. So 0 for y, or 1 for my x. So that is 0 is less than or equal to 4. That is true. So on my red line, I shade towards that 1, 0 point. And then I have one more line, which is my x is greater than or equal to 0. It is a vertical line at 0, so it's going to go right here. And it's greater than or equal to 0, so that means I'm going to shade to the right side because x gets bigger as it goes to the right. All right, so now I got a bunch of arrows. I got to figure out where to shade. I got to be above the blue line. Okay, I got to be up here. I got to be below the red line. And I need to be to the right of the purple line. So my answer is actually going to be this little shaded area triangle right here. which happens a lot when you do 3 of them, because like I said, a real life scenario, it's got to be greater than 0 on the X, greater than 0 on the Y, and you got supply and demand where it meets. What we're going to kind of talk about on Thursday is called linear programming, and it's like maximizing that region right there. The word problem is just a little hard to do. It's just kind of a long problem. But I feel like that's a good place to stop for today.